All right, so what we're going to do now is kind of put all the information together, think through, we're talking about a rhombus, a square, a rectangle, look at some information we're given, right? And identify which parallelogram is it? Is it a rhombus, a square, or a rectangle? So what we do know is that these are all parallelograms, so we're going to keep that in mind. Looking at part A, we have these two sides marked congruent. So in a parallelogram, opposite sides are congruent. So I'm going to just mark the sides opposite as congruent. So what do we know? We know that all sides are congruent. So which shapes or which parallelograms have all sides congruent? This is either a square or a rhombus. What else do we know? We know that BD or DB, however you want to say it, that diagonal is an angle bisector. And if we're bisecting that angle, this is going to make this parallelogram a rhombus. So when it says explain your answer, that's what we're doing right here. We're saying here's what we know, and because of this, we have a rhombus. All right, part B, what do we know? We know that the diagonals are congruent. So see how we have PR is made up of two congruent segments. QS is made up of the same two congruent segments. So diagonals are congruent. When your diagonals are congruent, this is either a square or a rectangle. So what else do we know? We also know that the diagonals are perpendicular. So when you have perpendicular diagonals and they are congruent, this is going to be a square. All right, part C. What do we know? We know that our diagonals are split into 5 and 5, 5 and 5. One diagonal is 10, the other diagonal is 10. So we know that the diagonals are congruent. And that's all that we know. We don't know anything else to get any more specific. So that means that this parallelogram is going to be a rectangle. If we were going to say rhombus or square, we'd have to have more information to narrow it down more than that. Also, I can't just look at it and say, oh, that's a rectangle because it looks like a rectangle. You have to be able to back it up. It's because the diagonals are congruent that we know that's a rectangle. All right, part D. What do we know? Well, I see a bunch of 45-degree angles that are being formed by this diagonal. So this diagonal is an angle bisector. And then we can even get more specific. We bisected these angles into 45 and 45s, so that tells us that this, well actually before we get there, if your diagonal is an angle bisector, that's going to make this either a rhombus or a square. What's the difference between a rhombus and a square? A square has 90-degree angles, a rhombus does not. So if we look at our angles, see how we got 45 and 45, it bisected this angle. So that full angle was a 90-degree angle before we saw how it was bisected. So we have right angles. Which makes this a square. All right, next one, what do we know? We can see that all the sides are congruent. It's a parallelogram, so we know the opposite sides will be congruent. And all four of those sides are the same measure. So when all four sides are congruent, this is either going to be a rhombus or a square. So what else do we know? We know that the diagonal is an angle bisector. So that's true for a rhombus and that's true for a square. over here, we were given more specific information to know that that was a 90-degree angle. Over here, this diagonal is just bisecting our angle, but we don't know if this was a 90 degrees. Like we don't know that we have right angles. There's nothing that can lead us to that conclusion. Even though I'll tell you what, it sure looks like a square, but we can't confirm that we have right angles. So this is going to be a rhombus. All right, last one. What do we know? We know that we have a parallelogram and the diagonals bisect each other, right? So this is just true of all your parallelograms. So I'm just matching the congruency. So if this diagonal got bisected, this half will be the same length as this half. If this diagonal got bisected, this half will be the same as that half. So I'm going to go ahead and match that congruency. And then what we notice is each diagonal is made up of the same congruent segments. So we have diagonals that are congruent. So which parallelograms have congruent diagonals? This could be a rectangle, or this could be a square. Those are the two parallelograms that have congruent diagonals. So for this to be a square, we would need all four sides to be congruent. They look like they are, but do we have any information where we can make that conclusion? And we don't. The only thing we know is that the diagonals are congruent. So the only thing we can say here is that this is a rectangle.